Welcome everyone. Welcome to yet another series on building with Amazon AgentCore. So today is going to be our second session we'll be having on this session. And with me today, I am having Vadim Kazukin. Did I get the pronunciation of your name very well? Can Vadim hear me? Okay. So we'll be having two speakers on board, Vadim and myself. So Vadim, yeah, you can speak now.
Y- Yeah, I can speak now. Yeah, you got it right um,
Oh,
with my
okay.
name. Everything's fine.
Thank you. So it is nice to have you on board.
Yeah,
So
thanks.
I myself and Vadim will be walking you guys through the hands-on session on building with Amazon Agent Core, and I hope it's going to be a very amazing session. I'm looking forward to what Vadim has in pack for us. So we'll be waiting for others to join us in just 1 or 2 minutes. So I'll be leaving just 1 or 2 minutes for people to join us. After which we'll be getting started with this session fully. So let's just wait for others to join before we start the program. Okay. So all right, I think it's time we get started. So we don't need to wait for more people anymore. It is just they'll be meeting us on the program. So I myself, I'm going to be one of the speaker, and I have Vadim here. So it will be my pleasure to introduce Vadim. So to everybody here, to my audience. So Vadim is an AWS serverless guru and the head of department at IP Labs based in Bonn. He has been in tech industry for over 25 years. That's very amazing. So I'm looking forward to learning more from Vadim. And he currently focuses on design and implementation of highly and scalable applications on the cloud. He has passion for serverless, generative and agentic AI, and as well works on optimization of Java applications on AWS Lambda. He's also a co-organizer of the Java user group called Meetup. He's a frequent speaker. That means we are going to learn a lot from him today. I'm really looking forward to the session as well. And he's an author of a lot of he's an author of a lot of articles, magazine and online blogs. So Vadim, we are honored to have you on our session today. Thank you so much for sharing your knowledge and giving us your time today. So, and I myself, I am Olanraja Basit. I am an AI engineer at Authorite Integrated and an AWS community builder. I'm an AWS community builder for the past 3 years, and now I focus on AI engineering and data engineering, and I love to build scalable systems, building systems that are agentic. So, and I hope we are going to have the best of our time today. So, without further ado, without taking much of our time, really, I've limited time today. So, I will be going ahead to present my own part of the session. So, after which, Vadim is going to present what he asked for us to talk. So, let me, okay. I hope my slide is visible now. So, the name of our session today is building and governing intelligent AI agents with AgentCore. So, we'll be looking into the architecture, the security, and enterprise integration AgentCore has packed with us for us. So, okay, okay. Vadim, can you hear me well now?
I hear you, but I also hear the music in the background. I don't know if
Yeah,
it's
I'll go
probably
down
you
from
need to
now.
shut it down because otherwise people don't hear you well. Oh, now it's better.
Yes, thank you, thank you, thank you. I put that off now. Yeah, okay. Let's get into it. I don't know. Once again, and I engineer has anticipated not relation to one of the because so hopefully you should be going into the enterprise integration. How about you? So I would love to know where you guys are joining us from. I am joining from Lagos here in Nigeria. So you can share with us in the comment section where you are from. We would love to know where you are joining us from. Thank you. So getting back to our application or our topic of today. So we are talking about agents, AI agents. So every one of us have learned or have seen the evolution of AI. So back in the days when you are chatting with chatbots, you are interacting with chatbots, you are or you probably see something like a customer service of any app, you know what it's like, right? You'll be seeing something like, what do you want? And then you'll be given lists of something you can talk to, you can pick. Then you have just only have to pick out of those things that are given to you. Okay, let's say I check into a network, internet provider service, and then I have an issue with them. I up into the customer service, a chatbot. So it's going to ask me, what do you want? I'll reverse it. And I'm going to say, okay, I want to unlock my SIM card, for as an example. So it's going to give me an option. Okay, pick from these options. A, if I said A or one, talk to somebody. Two, I want to do this. Three, so I don't have any other option than to pick out of those options. Or better still, I might have to pick selecting an individual that's going to talk to me. Then we have conversation. Maybe that person is going to do it better than the chatbot. So all those simple chatbots, we all know that they are stateless. If I should chat to the chatbots today, what I mean by stateless is that they don't have any memory in them. and they only follow a simple question and answer interface. No context, nothing. So you just have to answer what they are going to give you what you want. You pick from the options they give to you. Okay, other than moving from them, going to just normal chatbots that just have only some AI agents, a bit of some just an AI model at the back end. You are only going to interact with them, asking them just some simple question. They cannot solve anything complex for you. So then after that, that's the first generation of chatbots. Then we have the RAG system. So here now, the RAG systems, retentive augmented generation systems. So we know that these systems they have what we call the knowledge base. So they have what we call knowledge base. They have something at the back end, a knowledge base. So that gives us some more powers. That gives us more power to create something more. Okay, before we've been creating chatbots that are very dumb. Whenever you ask them some questions, they are going to tell you the only thing they want or they know, and they can even tell you something you don't. Now with RAG, we can create systems, we can create chatbots that are more sophisticated, can be specialized, specified towards a certain goal. Say, I can now create a chatbot to serve as a lawyer, given that I'm going to provide everything that I know about law, everything that I can find about law. I'm going to put it inside its base. That way, anytime I'm asking it any question, it won't generalize it and it will refer back to its knowledge base to answer my question. So that is the second generation of the RAG system, the retriever augmented generation that are now enabled us to chat with our data. We have data in the background, we can talk to it. So you can just even at times you might have to upload data to it, just like I gave the example here that summarize 50 page of this PDF. So the agent knows that he's taking the knowledge I'm giving to him and then it's going to summarize it for me instead. And the third generation that we are having now is the autonomous reasoning and action taking capabilities. They can make decisions on their own, they can act on their own. They can look through your database, unlock your access to something, tell you what you need to do to get something. They can act on their own, they can run processes on their own. So these are the agents. This is the current state of the agents, AI agent, agentic AI, the ecosystem. This is the current state of the agentic AI. You have to build systems that are autonomous, that can think, that can reason on their own, and they can make decisions and take actions. So now that we've learned of on the evolution, so we'll now go to what's the major problem that agentic core is here to solve. So now we've all might not all, but most of the problem, this might not be the day two problem, it might be the day three problem for your company, it might be the month two problem, second month problem for your company. But what I'm actually trying to say here is that one of the problem most of all face is that whenever we build whenever we build a system, yes, you test it on your local, right? You test the system, you build the chatbot, you build an simple AI agent, you build something like a translating system. Okay, this thing is working perfectly on your laptop. What if you now push it to production? That's when you start having problems. This is not a system that only you is using anymore. This is a system that many people are going to use, right? So now the major problem here is that the beyond the prototype, after the prototype, you build the prototype, now you are the only one using it. But now you have to extend your prototype to the end of the world, to the rest of the world to use. How are you going to balance that? How are you going to make your system now work for everybody, not just only you again? So building a proof of concept agent in Jupyter Notebook takes hours, right? If I want to build an agent on my Jupyter Notebook, it's only going to take me some hours to build that, right? So, and it might even take me lesser to build that. But that's just the one. That is just on my laptop. That's just on my laptop. So the production reality challenges is that how do I manage the conversational memory for 10,000 concurrent users? I'm having 10,000 users. I'm having a lot of users on my app. How am I going to manage the conversation? How do I securely store and rotate API keys across environments? These are other problems you have to now to look into. How do you audit and explain why an agent made a specific decision? How do you audit your agent? This is one of the major problems you're having in the ecosystem. In the agentic era now, how do you auditing your AI agent, knowing why it is making that decision it is making? Is your AI agent still doing what it's supposed to do, or is it now acting on its own, doing something that is not necessary? So auditing your AI agent is one of the most problem we people face today. Okay, now we have the Amazon agent. We have agent core. So agent core is a framework agnostic infrastructure. So when I mean framework agnostic infrastructure is that whenever we are building a system, whenever we are building agentic AI, we are building AI agents, we work with a lot of framework, be it Crew AI, be it LangGraph, be it LangChain, anything, be it trans agent. So you can now work with anything, any of your agents, any of your framework when you are using agent core. So it's a framework agnostic infrastructure that is designed specifically for production AI agents at scale. Agentic core is built with production at scale behind at the mind. The main one of the main reason it was produced is that you can use it to build agentic AI for production, not just testing on your laptop, not just working with it. So if you look into mind of building an AI agent into production, then you should think of using what agentic core, agent core rather. So and it doesn't have anything to do with what framework you work with. So you might be a land graph person, you might be a LangChain person, you might be a Crew AI person, you might be a transition person. You don't have to bother as far as you are working with Agent Core. So what Agent Core brings is that it has managed infrastructure. You don't need to manage any server. Your agent is running fine and good where it is, and then there is going to be automatic scaling and high availability of your agent. So you don't have to bother whether I have a lot of people joining at the same time. It is going to scale. Okay, I have just only one user. It's going to scale. That's one of the solutions Agent Core is here to solve for you. So that's one of the problems Agent Core is here to solve for you. That's one of the solutions it is going to present to you. It is here to present to you. So and high availability. You don't have to worry about your systems running down all of a sudden. So now we are going to look into the core architecture of Agent Core. Agent Core has quite a number of architecture, let me say number of let me say architecture in it. So I count about 6 to 7, right? But then the one of them, the most three one that are the most important one there. The first one is the runtime. So we have the runtime. So what does the runtime does for you is that it's going to ensure that you have a session that is isolated. So session isolated is so isolation is one of the things that the agentic runtime, the serverless runtime on agent core is going to give to you. So serverless runtime on agent core is going to give you session isolation. Every user interaction spawns a micro VM, and it is going to happen. That's going to work only in isolation. There is zero data leakage. We have thousands of users using the system. Each of them are using your app, and there isn't going to be a single interaction between one user and the other user. There's going to be zero data leak between them. So another thing is persistent support. So we have long running processes are natively supported. You can tell an agent to run or engage something for 30 minutes and it's going to find, and then it's going to scale perfectly. That's the third option. That's the third benefit. It's going to scale like the elastic scale. It can scale automatically from 1 to 10,000 plus concurrent users. So without wasting much of our time, so another core architecture of agent core is the memory, the intelligent memory. So here we have two type of memory. It has dual layer memory architecture. The first is the short time. The second one is the long term storage. So that long term storage comes in form of summary. So whenever you have made a conversation with your agent, so agent core is memory is going to summarize your conversation and is going to store it long term in that long term storage with context, so that whenever you are to come and request for the same thing you said before, it's going to retrieve, it's going to collect everything you've said without losing a word. So short-term memory, active context window maintains immediate conversation states and recent interaction for real-time decision making. As for the long-term storage, it gives you persistent memory across sessions. When the user mentions, "I prefer gluten-free food on Monday," it just remembers this preference on Friday. That means the user has talked to the agent about that Friday plan before, and the agent is going to remember that you said you like this gluten-free something on Friday. Why are you changing it to on Monday? So, and then when you're working with agent core, you don't have to do any database management. Zero database management is required as far as you're working with agent core. So another thing on agent core that you, as one of the core architecture of agent core, is the gateway. The gateway gives you a lot of access, gives you a lot of power in agent core, whereby you can turn your APIs. It gives you the ability to turn your APIs into tools or MCP. So you can connect your agent to your database, you can connect it to your Lambda function, and they are going to be working perfectly. So I can see you are calling a tool. So you can turn your API into a tool on your agent using agent core, and then you're going to be using that your gateway in the agent core. You said to connectivity. Agents require access to enterprise tools, including REST APIs, database, AWS Lambda. This two connectivity is one of the things that the agent core is going to give you. So another thing is the gateway automatically transforms standard APIs into model context protocol formats that agents understand natively. So one of the things that the gateway gives the agents is that it's going to allow you to interact with RESTful APIs, giving them more context so that your agents can understand them easily. And then dynamic tool discovery. Agents can dynamically search the gateway catalog to discover and select the right tool for anything they want to do. You can talk to an agent now, said, how much am I owing this social person? And you can easily know that, okay, I'm going to go into your DynamoDB to go and search for the debt you are owing this social person. Just calling a URL, an API to your DynamoDB to go and check that. And he knows when to use that your DynamoDB API, or when to go and check your data for another thing else. So it's not going to mix anything up with one another. I'm running out of time. I have to round up early. So and then we all know whenever we are working with anything agents, talk we have to talk about the agent's behavior. How does the agent behave? So agent core has what we call the context injection, which makes your agent behave in a well-mannered behavior. So naturally, we are going to give our agent system prompts. So even when you give your agent system prompts, some agents will still behave abnormally. So agent core has this context injection that makes you work, that makes it performs better, and then you can use any model when you're working with your agent core, from Cloud to Amazon Titan to anything, and you know that your cost optimization principle, like it matches the model capability. You can work with multiple models even, and it's going to be using each model according to what they are supposed to be using. They are supposed to work on. It knows when to use an AI agent that can go for research, and when you want to ask for something like just add 2 plus 2, it's going to call another model and it's going to optimize your cost for you. So and the routing patterns, It knows when a query arrives, complex analysis, simple query, and then it does the same thing like I just said in the model selection. And it knows when to prioritize each transaction or each query to the other. So integration patterns, we have the gateway pattern, the event-driven architecture, and the embeddable runtime. I don't want to take varying time, so I'm going to be wrapping up easily and very fast. So another thing is about the governance. So you can easily give an agent call and you can give it access to things, and you can also restrict its access by giving it policy. Okay, what do you have access to? You can do this, you cannot do that, and it's going to work perfectly the way you give to it. So the key takeaways from this session is that focus on your logic. Don't stress yourself. Focus on your logic. Agent call handles the state management, authentication, and scaling. Just build. And you should know that Agent Core has the built-in security. You don't need to bother about your security. And the next thing is that you should start simple and scale smart. Begin with one agent and two, and then expand. Agent Core is what you need to build the next production scale AI agent. And that's all. Thank you. So I'll be I'll be leaving floor I give the floor to Vadim to start his presentation. I don't know if anybody has any question, you can send it to the chat, to the comment section, so we can answer that at the end of the session together. But in the meantime, I will ask Vadim to come up and take the stage. Thank you, Father Vadim.
So I now try to share my screen and see if it works. Can you? I don't see
Okay.
currently my slides. Can you put them live? Because I see them on my screen, but I don't see them on the stream. Hmm? Yeah. Can you put my? Yeah.
They are now live. That's now.
Okay. I see, but I give me 1 second. Uh, so maybe that will be now better. 1 moment. Yeah, the problem is you are seeing my reference thing. Let's try maybe this. Currently not working. Please give me 1 second to share. I will share maybe with that far. Okay, waiting to see what will be shared on your screen. Can you bring the presentation now? To sorry, can you put me live because I see on the stream that there is no presentation running currently. Okay, let's try once again. Uh, so now put me live. Can you bring the slides back because the people only see me, but not the presentation?
Hello, Vadim.
Hi,
Okay.
please, please help me with that because I'm not live. I see on the YouTube that there are no slides.
Slides should be showing now. Okay, let me add it to stage. Okay.
I hope it's not the
Why
presentation.
is it not
It's once
showing?
it's once again the wrong one. It's a presentation view. I don't know why. Maybe I will share the whole screen and it will be better. Uh,
Yes. Is it this?
okay, if I okay, but if I change the slide, you don't see it. That's a problem. Oh, now you see it. Okay, okay, now it works. Now it works. I think we can start finally. Sorry for some delay. I have only
Yeah, yes,
25
we
minutes.
can start.
Yeah, I have only 25 minutes, but I would like to dive deep, at least in certain points of Agentic Core. About me, I like serverless, Java, Agentic Core, all that stuff. And they have been already told by the previous speaker many things, but I would like to show you some code. There have been questions about can you write the agents with strengths agents framework with Python. I will show you some code, but only I will only dive deep into gateway and runtime and leave memory identity and observability to your own, but I will share the link to the presentation so you can look into this. So the challenges have been already clarified. The production looks differently as, for example, the local environment, and you need scalable infrastructure, and that's why many proof of concept kind of don't work. And that's why agent core come into play, and it enables you to deploy and operate highly effective agents securely at scale, any framework, any programming language. And agent core really accelerates this. And the most important parts, these bedrock agent core services are composable. Yeah, so you are not required to use them all. You can use agent core gateway to provide gateway to your services and run your agent on other platform than runtime. You can do this. You can use observability providers not baked by CloudWatch. It's possible. Yeah, so this is the huge benefit. And yeah, I will dive deeper into agent core and runtime. So how I came basically to this to agent core. I had this serverless application, yeah, which stores the data in certain database. It's already SQL, but it can be DynamoDB, RDS. It just doesn't matter. I have API gateway, a bunch of Lambda functions to create order, get order by ID. And the thing I was asking, can I talk to this application using natural language? and it wasn't possible previously, or at least not easy. Yeah, you can, for example, install or check out Aurora DSQL MCP server and run queries against this server. There is one for DynamoDB and so on. It works, yeah, but you connect directly to the database, and sometimes it just doesn't feel right to talk directly to the database. So for me was the question, can I convert existing services to kind of MCP servers, and if yes, can I expose those services? And then Agent Core Gateway came into the place which exactly enabled me to do this stuff, and it was kind of a relief. Now I can finally do this. And Gateway already was introduced. You can secure and deploy and connect tools, which will be, the tools will be exposed as MCP tools. MCP is a protocol for doing the stuff. There is also agent to agent protocol. I only worked with MCP now, yeah, and we can convert any APIs, open API specification, REST API specification, not hosted on AWS, but you can also convert existing Lambda functions API gateway to MCP tools. Yeah, and these tools give access to the data that we own, like the orders and so on. So the models don't know them. Yeah, this is specific information which is only available in my system. You cannot train the model, but you can provide the model with these MCP compatible tools, so that the model, they are so um, um, capable now to decide what tool to call. And Agent Core Gateway acts like an MCP server, basically, uniting all as a single access point. So now, yeah, the picture might be even outdated, and it's I will show you, because you can do more and more stuff with the gateway. Yeah, I will show you the first thing, REST API. Yeah, how you can connect REST API, but there are also other third parties, PagerDuty, Amazon. You can do a lot of stuff and expose those APIs. Uh, of course, only the tools that you need to your application. And yeah, there is a possibility to connect Agent Core to every open API. It can be weather API outside. In my use case, it will be API gateway on AWS, because I host everything on AWS. But once again, you are not limited to this. Yeah, you select here REST API, and you need to provide the location. You upload um, the schema on S3, where you basically expose what APIs you would like to connect to those tools. Yeah, so you need to create this open API as a target and define this, and there is a specification for this open API specification. You say the server URL, in that case is the API gateway URL, and you need to define paths, because your API gateway or your gateway can explore or expose also write operation. You probably don't need it. I have create order, but I don't want to create order via the agent. I would like only to talk to it, like only read only methods. For your use case, it might be different, but here you see I expose order, get order by ID. You see on the right side the path to order. I say orders ID, and I also expose get orders by created date, so that you can get all orders like created in January. You pass here parameters. In the first case, it's ID of the order. In the second case, it's start and end date. As you see, this is pure open API specification. And if you upload this to S3, basically then those tools and all these tools that are under paths will be discovered as MCP tools and exposed to that. In the end, the gateway URL will be generated. You see this has in the red one, the /MCP, and it exposes the MCP server with HTTP streamable protocol. So now the question is how to talk to this. You can use any framework. Once again, I will use AWS own Strengths agent, and it's lightweight and gives very easy access. Yeah, you can use other models, not only Bedrock. It just doesn't matter, but it's very well predefined with defaults, like to talk to AWS own models. Yeah, so Bedrock is, for example, the default one. So this is the Python framework. You expose many things. You define this gateway URL that we saw previously, and we then can run their agent. First of all, we do it locally. Yeah, so we define this MCP client, which uses streamable HTTP streamable protocol. We provide agent core URL, gateway URL, which acts as an MCP server, and we need to obtain the token. token to talk to this. This is GVT token. You need to use Cognito. This is nothing specific to Agent Core Gateway, but I will not cover it in depth. But this is the security mechanism, which is kind of part of identity to provide outbound communication. And then if you connect to MCP tools, you can ask list tools, and then this get order by ID, get order by created dates will be exposed as the tools. And basically then you can use the agent. The default model is Bedrock, but you can create the object Bedrock model or Open API model, and you need to provide those tools as a list that you got from the MCP server. You can also add another tools. If you Strengths Agent has its own tools to writing to the file system, calculator, web search. If you need that, you can provide this. You are not only limited by the tools provided from this MCP server, which is the Agent Core Gateway. You can do what you want, and then you provide your prompt. In this case, please give me the information about order ID 1234. Will think that this order exists, and you simply provide the model and the tools that you got from a MCP server. Basically, I told you, yeah, exactly this, yeah, and the agent prompt, and the prompt will be passed to the agent, and agent will look, what tools do I have? Do I need a tool? Can I answer this question without tool? If not, they will go through those tools, and if that, then the tool get order by ID will be selected. If I'm asking to provide the order by ID, if I ask, please give me all the orders for the month December 2025, then another tool will be selected. This is kind of the example. You see, give me the information about the order, and then the agent will do, I'm thinking, retrieving the order 12345, and it says, I need this get order by ID tool in order to do this. And then it will ask, yeah, then the request will be passed to API gateway, which then is connected to my Amazon gateway. And then this API call, get order by ID, will be executed, and then Lambda function will be called of the sample application. So this is the way to go. This was another example, just the same. You are not limited if you don't have the formal API, and you, for example, want to talk to the existing Lambda functions, which also provide the business value. You can do that. Yeah, you don't need to create API. You can expose Lambda functions. This is basically the same as here. You provide a Lambda IRN. For example, this is get order by ID Lambda function. Yeah, and I provide the tool name. It's very important to name the tool, get order by ID, and give the description and give the parameters. Yeah, because the tools will be discovered by name. And this is the same for another Lambda function, which provides the functionality to retrieve the order by created dates from created. And just the same, you see here, order by these created tools. We have two parameters, two properties, end date and start date. And that's it. Basically, you now have the gateway with two Lambda functions. And you can mix them. You can add more targets. You can mix the targets. You can have targets Lambda function plus open API specification if it fits your need. Yeah. You need to think about that too many tools may be difficult for the agent to select the right one. So you can only, please expose only those tools that you really need to provide the job, and exclude all others. And yeah, the thing was, as I started to experiment it, even if I hosted API on the Amazon API gateway, I needed to do this dance with open API specification. Later, last year, there is a direct connection to API gateway, and it makes things easier. I simply select my API gateway and stage, and then I can select the API operations. Once again, I select the read-only operations, get order by ID, and get order by created dates. Yeah, this is kind of important. You need to give the name and description, because it's not the part of API gateway, so you need to override it here. I don't show you the infrastructure as a code part. I only show you more or less kind of how you will do it on the service page, but then you just see. Yeah, and then the API gateway is created. Really cool stuff. Yeah, so once again, you can mix. You can even deploy your MCP server. If you have already created some MCP server which you used locally, you can deploy it as a gateway and also talk to it. Yeah, so you can have the unified gateway pipeline consisting of FCP servers, open API specifications, Lambda functions, and in API Amazon API gateway. Yeah, but only that you have the possibility. You don't need to use it. Think. So what do you have, and what do you need for agent to be successful? And the second part I would like to show you, okay, we run the agent locally. Of course, it doesn't scale. It's your local environment. You probably understand it's just not the production need. Yeah, you can deploy. Strengths Agent is a Python application. It's a Python code. You can deploy it anywhere on EC2, ECS, EKS, Fargate, option on AWS Lambda. But there are, of course, challenges specifically for running the agent. Yeah, and runtime provides the solution with a secure serverless, as the previous speaker told us. There's no server to manage. It's framework agnostic. There is a lot of flexibility, and it provides you the way to talk to the agent through different protocols. I will focus on HTTP protocol, but you can also deploy it as an MCP server. Yeah, it's a bit different than deploying MCP server on the gateway, because it's more like a gateway pipeline. Here you can deploy your MCP server and run it on the runtime, just to benefit from the scaling. And you can use also A2A protocol kind of and deploy it there as well. But once again, I will focus on HTTP. And the thing is, runtime supports real interactions and long running workflows up to 8 hours. For example, if you have such a long running workflow, you probably don't want to use Lambda. You cannot use Lambda, which has a 15 minutes limit. But if you have short-lived workflow, it will be too expensive maybe to use the containers or EC2. Yeah, so this is kind of the runtime. AgentCore runtime provides the right balance. And this previous speakers also told about session isolation. Yeah, it's very important that on that after you just finish the job, then the environment will be completely destroyed, and nobody can just see the information that, or the things that your um, agent did. And it's done by Firecracker. This is the technology which is powered, also powers Lambda and also the SQL database. Yeah, and it provides the right level of isolation. And the cool thing about Firecracker, that it's just context can vary from bytes to gigabytes, and the Firecracker VM can grow and shrink in memory. And in CPU just in place. If your agent probably needs more data, or kind of handles more data, then it can instantiately grow, and the startup time is just milliseconds. So how to do this? You have two possibilities. If it's Python application, you can upload the code right away, yeah, as a on S3. But I will show you that you can use ACR, like to deploy the container. And it's basically, there are many possibilities to do it. I will show you only the first one with the starter kit, which makes certain things easier, that you don't need to mess with too much with Docker files and uploading them and writing and running the code build to build the stuff and upload it to ACRs. So there is the Python SDK, which makes things easier. And you see how it is. We more or less now transform our code that it can be run on runtime. And for this, we have kind of this annotation app, which is Bedrock Agent Core app, and we annotate invoke method with that, so that the runtime can understand this is the entry point. Yeah, this is the starting point, like main function of the application. And basically, this is the same what we did. We get the prompt, we instantiate the model, we get the token. This is the security part. We create MCP client by providing this Agent Core gateway URL, get the tools, and so on. But how to deploy it? On the right side, you see that's very easy. Agent Core configure minus entry point, and then you point to this Python file, which is on the left side. This is your agent. And basically, you need also to provide the IAM, so that because your agent can talk to gateway and so on, you need the permissions for that. That cannot be generated. The default ones only looking how to get the code from ECR repository, how to write logs, but your business logic needs, yeah, you need the permissions for that. So that needs to be created. And basically, then you say Agent Core launch. And if you say -L, it will be launched locally. And if you say simply Agent Core launch, then it will be deployed on Agent Core runtime, and everything else will be handled for you. Basically, you only define requirements, txt with the dependencies, and then the Docker file will be generated for you. It will be uploaded to the ECR via starting the code build and so on. So basically, you have it right away. And then, yeah, this is how Agent Core runtime looks like live. Yeah, you see here, yeah, this is the deployed runtime. You see here that the endpoint is always default, but there is associated version Yeah, there are versions because you can update your code and deploy this to the same runtime. And you see that the last associated version here. This is the version 2. This is which is currently live. Yeah, but you will probably have more versions. Yeah, and you see here in this case this is the CR image URL associated, but it can be also in case of Python, you can deploy it to S3. Yeah, but if you use Java and so on, once again, runtime is framework and programming language agnostic. You can use any programming language. Then you will need to go through the deploying it as a Docker image, and then you can talk to this agent. There is in the service page. You can also test the agent by providing the prompt, and you see the result is basically the same, like, yeah, give me the order ID, give me the order by ID, and you see the output here. Yeah, the order with details. This is some faked order on the right side. Yeah, you can invoke the agent. This is the Java code. It just doesn't matter. Um, yeah, or you can use the Python SDK just to invoke the runtime. So yeah, there are other possibilities. You can have more control if you deploy the fast API server, like the web server, not without this SDK, Agent Core, launch, and so on. Uh, it works basically the same. It exposes two methods: invocation. This is the entry point, so you need to have the post method invocation and ping for basically health check. Yeah, so this is then way then this is more or less the same code. You see here on the right side annotation of invocations, post method, and this is the business logic that you saw. This is the entry point, and there is the ping one, the ping method, and you have the fast API for just starting the web server. And then it's up to you. Then you are responsible for creating the image or uploading your Python file to S3. Yeah, there is no SDK here, but you have more control what you do, basically. Yeah, and the output is more or less the same. Um, yeah, this is basically what I wanted to talk, because the time is limited, but of course it's not the whole story. Yeah, you need memory, as the previous speaker told. There is a short-term memory, long-term memory. Now there is also episodic memory, because the agents are stateless and they forget the information. If you ask the question and you ask the next time, it will work once again, because nothing is saved. And sometimes you need something in between, and you can store it in the file session manager or S3 session manager. Both are supported with Strengths SDK, but of course, it's not the solution that really is required. You need short-term memory, long-term proper handling of such a memory, and probably I will show you at least short-term memory with several seconds. Yeah, it captures raw events, and you can more or less store the stuff in this memory. So the whole prompts and answers from the assistant, this can be stored up to 365 days, but you define this period. And here you see here, I'm creating the memory, a memory client, and say expiry day 7 days. Um, and I don't send the strategies. If I don't send the strategies, this is a short-term memory, but the strategies will be long-term memory. And then the memory is created, and the Strengths Agent SDK supports the lifecycle hooks, where I can simply hook the stuff. Yeah, and how it works, basically, for the short-term memory, I need those two hooks: agent initialized event and message edit event. And I need to implement this hook. It derives from hook provider from Strengths agents, and I can register those hooks. And basically, uh, then I can implement this on message add method, and then I will store the interaction in the short-term memory. And in case I ask the agent to do this stuff, I can retrieve the information from the memory. Yeah, and say, okay, look here, this is the self memory get last cut turns, how many last interactions will be kind of prefetched. Here I say 5, you can say something more, but it will be then added to the system prompt. Yeah, and this will consume more tokens, because system prompt counts towards the tokens. And then you can ask those, for example, following questions. You can ask informations about individual orders, and then you can ask, can you please summarize all the orders? So can you please give me information about the total value of the orders? And then with the memory, then the information about these orders will be kind of fetched from the memory, and not asking the agent once again, and then the information can be consumed. But you need to fetch this number of terms parameter, yeah, because if you only fetch the last 5 and you ask about 10 orders previously, then the agent only has the information about the last 5 orders and can only summarize their total values and not what you want. So you need to think about, but you can do such a funny thing that start the conversation and say, my name is Vadim, the weather is fine, and then in one of the later questions ask, what is the weather today? And yeah, if it's stored in the memory, it can be retrieved. This is basically what I wanted to say. Observability is very important. Check out CloudWatch Gen AI observability. The things, the traces, logs are stored, and for this there is a separate service, CloudWatch Gen AI, which provides you traces like X-ray and all this stuff. And that's very kind of important. You need this is even hotel compatible. Yeah, it's not AWS own format, so that's why you can use other third-party providers. Yeah, check it out. Without it, it's very difficult to debug, to understand what models, how many tokens did you consume, and so on. But basically, the message is all those services are composable. That's once again very important. You decide what to use, what to combine. Sometimes it's of course makes more sense to stay within AWS and use those services. And yeah, I will provide the link to the slides. I created a lot of articles on Dev2 about those topics where I went into the details, not only with Strengths Agent, but also with the Spring AI for Java developers, where I also explain how you can do the stuff, even if there are currently some missing functionality. But the teams on AWS are working together just to provide native integration for Agent Core and Spring AI. Yeah, that's basically it. I made it right on time. And thanks once again. If you have any questions, you can reach out to me. I'm on LinkedIn with my surname. You will find me. There is a homepage, uh, so I'm easily identifiable. So if you have any questions, please ask them. And thanks once again for the invite and listening.
Okay, thank you once again, Vadim. So we have quite a lot of questions. So, so this is the first question here. You said, can agents created with AWS Strand connect to Agent Core? I believe that's so. Just like you've shown from your presentation. Or would you like to say more about this?
No, no, this is the question was asked during the presentation of the first speaker. So I hope I showed you exactly that. So that's exactly the purpose of AWS Strengths. But of course, yeah, it's once again also agnostic. You can connect Strengths to any MCP server, for example. Yeah, I showed you MCP server hosted on Agent Core Gateway, but it's MCP is a protocol, so you can talk to Atlassian MCP server, whatever you want. Is
So
it possible?
another question we have, yeah, thank you, is that is it possible to partition memory? For example, if you have a multi-agent app with let's say 5 agents, can memory be partitioned for each agent?
So with the short and long-term memory, you can set two parameters: session ID and actor ID. Yeah, I showed you the static values, but if you say I would like to distinguish the agents, you can say set different actor ID. Yeah, so each actor will have its own actor ID, and then if you retrieve the things from the memory, you pass both parameters, session ID and actor ID, and with that only that specific memory will be retrieved. And with that, you need to think, of course, how just you assign the ID to the agent so that you don't mismatch them. This business logic is more or less on your on your side, but yes, it's possible.
Okay, thank you. There's another question here. He said, let's say agent A can access and update the memory of agent B or C. I believe maybe that's from your presentation or something. Is that possible? Can an agent have access and update memory of another agent?
Once again, you can configure this with session ID and actor ID. Yeah, you can say the agents A, B, and C have the same session ID and actor ID, and the agent D has different one. So you can separate them with these two parameters. Basically, you can also use these parameters to separate the users who send the prompt. Yeah, so that, for example, one in my example, one user is asking question about the orders, and then another user is asking the question about the users of these orders, and you can separate them so that not the whole information will be retrieved each time, and they are kind of, yeah, they are dealing with different questions so that they don't use the same shared memory, which will kind of cost money each time, so that useless information will be retrieved. So with those two parameters, you can basically like differentiate things.
All right, thank you so much, Vadim. It is nice having you. So this will mark the end of our session for today. It is nice having you here over again, and we are honored by your presence. So everyone, thank you for joining us, and we will look
Thanks a
forward to
lot.
seeing you throughout this session as well. We are going to have another session tomorrow till Friday. So see you guys around, and thank you once again, Vadim.
Yeah, thanks once again for inviting, and yeah, enjoy other 3 days of this event.
All right, have a nice day. Thank you.
Yeah, thanks. Bye.